For today's session, let's set the stage around a single problem. So let's say there's an independent movie company want to invest into making a new movie. And they want to be able to understand what type of movie that people like to watch the most. And they want to rely on data collect from a publicly available recommendation service. This is from MovieLens. This is a research group come out of the University of Michigan, I think. So basically, they have a website that run and get reviews on a movie, and they make the data available to researchers to use. So basically, the data set contains roughly 22 million ratings and 586 tags across 34,000 movies. And the data was created by 247,000 users between 1995 and 2016. The total size of the data is about 500 megabytes, which is a good size for a tutorial session. But basically, the nice thing about Hadoop MapReduce is once you figure out how to do it, it automatically scales. You can take what you develop here and apply to a movie that has billions of rows, and it would scale out in terms of performance accordingly. So, using this data set, several analyses are possible. You might want to find a movie which has the highest rating over the year and identify which genre is that. You might want to find which genre can get the highest rating, or you might want to find a user who rates movie most frequently and try to identify them and establish contacts so that you can have in-depth marketing analysis. So this kind of analysis, kind of ambiguous in nature. It is not simply a query to a databases. So you need to be able to process massive amount of data very quickly and somewhat repetitively. You might want to run a query for to go through this data set and limit that for 5 years, but then you might want to go back and change the time frame. So in this kind of situations, the size of the data make the analysis done on a single machine impossible. And if you want to do the same analysis on a remote system, it's becoming impractical as you start to have to move very large amount of data across the network. So basically, we'll look at how HDFS can support this type of analysis. So with that, let's first go through on how to interact with the Hadoop cluster. We have here, so most of you know about the Palmetto supercomputer. We also have another infrastructure that was only up about a year ago. It's called the Cypress cluster, and this is the university Hadoop infrastructure. So let me bring that up. We don't have the new notes in here yet. Yeah. Do you want to talk a bit about the new nodes that we have?
You want to mention what we have currently?
Yes. So this is underwhelming at the moment, but we just got a new batch of nodes that it should be in operation by the end of the summer.
All right, so the nodes we have currently. There's 3 master nodes which run what we call master level daemon services. And so those would be like the metadata server for HDFS. If you don't know what a metadata server is, it essentially lets users that interact with HDFS and the other HDFS processes understand what data is stored where in this distributed file system. So 3 master nodes, and then we currently have 16 worker nodes. The worker nodes is where your processing will occur, and it's also where your distributed data will be stored. And so Lynn mentioned that co-located data model where you do the processing on the node that already owns your data. So when you copy this data, these big files into HDFS, they'll be distributed across these 16 nodes. And then when you run your analysis on this data, it will also be distributed across these 16 nodes, where you can just read the data from the local disks and not have to send it over the network. So each of the Hadoop worker nodes has 12 1 terabyte disks currently. But we're really excited to let you all know that we just got 24 new Hadoop nodes. And these things are really beefy, if you will. So they have 24 6-terabyte hard drives on each node. So 24 terabytes times 24 nodes. I'm sorry, 6 terabytes times 24 drives in each node times 24 nodes. That's a lot of storage. It comes out, when you add it in as the existing nodes, worker nodes we have, it comes out to about 3.6 petabytes, if I remember correctly. So it's a substantial resource, and you have a lot of data that you might analyze or learn about to do if it's a good resource. So we'll be adding those 24 new nodes into this cluster as soon as possible.
Thanks. All right, so let's start with the Jupyter. I think all of us went through the Jupyter session. You can go ahead and create a new terminal. You can pick whichever terminal you want. I usually go with the Python 3 Anaconda.
Oh, I forgot to mention, sorry, I forgot to mention each node has 256 gigabytes of RAM. Each of the worker nodes does, and has at least 12 to 16 cores in each node. So it's capable of doing a lot of processing very quickly.
Sorry. So before you create a new notebook, the notebook is going to be created in the current directory that you are in. So go ahead and create a folder called, what you hit new on folder. A new folder is going to be created and named untitled. You can check on this and go to this option. You can rename that folder. So rename that to intro. What did I use? Intro to Hadoop. Click OK, and this will be changed to Intro to Hadoop. Click into the folder. You see that this is an empty folder with there's no notebook list. Go ahead and now create a new notebook, and you can see that you have a new notebook named Untitled. Change the notebook name to Introduction to Hadoop. And change. This change accordingly. So anything that we work today from your notebook is going to be stored within this workspace. And once you finish working and you go back and you launch this again, everything that you have done today is still going to be stored. Yes?
What resources do we ask for when we request a notebook?
1184.
Right, thanks.
So I store my notebook somewhere else, so I need to go back out and get to them.